Hello and welcome to the first Arduino workshop. This will be a very basic workshop and it's for the project Microgreens of Technologos. We have to talk about first this board, an Arduino, what it is, what does it do, etc. And then we're going to talk about how we use it with the concept of microgreens. And it's really easy to get started no matter who you are and no matter how much is your budget, because this is a very cheap and easy way to start with a tiny computer. Because this is what this is. It's a tiny computer that's very cheap, it's very efficient, and also it's very versatile. We can use it for many functions. So what makes an Arduino so cheap and portable? Basically, we first have to look into the board to see why. We have a microcontroller that's basically this here. And what this does, it acts as a processor, memory, and many other things. This is a Wi-Fi variant of the newest release of Arduino Uno. And other than the microcontroller, which acts as our computer, it's got everything that a very small and weak computer can do. But that's all we need it for. We don't need anything else than this. We have a USB Type-C for debugging code that we write for this, and also we have power in. And other than that, what we will focus on today is the small pins that we have here. So we are talking about some analog pins that we have as input, so we can use it for all sorts of accessories, which is another one of the advantages of Arduino we will get into later. And also we can use it for some digital input and also give 5-volt power to our accessories that we're also going to talk about soon. So this board, not only is it cheap and it's efficient, although it's very weak, it cannot do what our laptop can do. We don't need it to do what a laptop can do. It's very easy to code for, even kids do it in schools. And it's got a wide range of accessories. As you can see here, I have a temperature sensor that we're gonna hook up to the board later to get a reading from it. And it's very easy to connect it with other programs. So we can use this as an input sensor in, let's say, a microgreen, where we can have it get a bunch of input data and then have it in our program that we're gonna code for to do anything we want for it. It can be a very cheap and efficient way to connect something on the spot to get a bunch of information without having to take a whole laptop or desktop computer there. And it's also open source, so it's great to work on, and it's got very many examples. Whatever you want to do, there's probably a code that someone wrote for it, so you can learn about it very quickly and efficiently. So it's easy to see how this can be a better solution to use for our microgreens project and for many small projects where a tiny computer is much better than to have a big desktop or laptop computer taking up a lot of space, a lot of power for no reason. So let's say it's a better use case. It's all about the use case. We can have more Arduinos than just one computer connected to many sensors in our microgreen, which is better because we can achieve redundancy for cheap. If one Arduino breaks, it's very cheap and easy to replace it, and we can still have another backup option, whereas a laptop can cost like 500 euro and then you have to replace the whole thing. And we can also make a bunch of additions to it. So we can 3D print a case for it, or we can include other parts. We can buy all sorts of components and configure it however we might want it to. Okay, now that we have introduced the topic of Arduinos, let's go a bit more in depth and look at some examples and also see some components that we can connect up to this thing to make it useful. Let's start with what we call sensors. A sensor is basically an input to anything that we want to make, any project. For example, this here is a temperature sensor, and it's got 3 pins. From this view here, the leftmost is the ground, because this is about electricity. The rightmost is power, and then the middle is the digital digital input to the board. There are also other sensors that have only 2 inputs, and those are what we call an analog sensor, and depends on how much electricity passes through it, and that can determine something. For example, we can have a button, so if we press the button, we close the circuit, and so electricity goes through, and then the button is pressed. That's how we know that we have pressed the button. We can also have a knob that we can spin, and it lets us know how much or how little of something we want to be active. We're not going to show anything like that today, but there's also what we call effectors. Effectors are basically output to something. Let's say we want to have an LED that will blink whenever something happens. For example, if half a second passes, it will turn off, and another half a second passes, it will turn back on. We can have that work through our circuit that we can build using these pins that we've talked about, the digital and analog ones. Some essential electricity knowledge is required here, but don't worry about it, it's not too difficult. We have here a cable that can just plug in to one of these ports. Let's just connect it to the 5-volt output, and then it can go to what we call a breadboard. A breadboard will just take in lots of cables and help us make a circuit without the need of any soldering. So if I connect the 5 volts to this positive row right here, we can see that everything that's connected to that row marked red will have 5-volt power, and that's a very specific feature of breadboards. So as you can see here, the 2 sides here, the 2 rows, are all connected from the top down. But for these middle ones that are not marked, black or red, all of these are connected horizontally and not vertically. So A, B, C, D, E, F, G, H, I, and J are all connected, and not the whole row from 1 to 30. So let's say I had an LED and I connected with, let's connect this back to power. And imagine I had an LED somewhere around this row here. Because I wanted to have power, so why not connect it to this row that has power, right? That's not gonna go well. The LED will break, will pop, because the LED, as in every other component that we can have, has different voltages, and it can operate under different circumstances. So we can't just do that and connect anything that we want and just hope for the best. We have to see how much resistance we need, and this is where these come in. So this is a resistor right here, and the colors on top of them, they let you know how much resistance they will give out. So this is a 4.7 kilo ohm resistor, and we need this to connect the temperature sensor. Let's continue building on this example and add another component on top of it. So we have this entire row connected to electricity. What we can do is take one cable like so and connect it from any of these pins on the side that has electricity to any of, let's say, these ones. Now I have connected it to column 21. So everything that's connected to column 21 will now have 5 volts power. So we can continue with connecting a bit more of the components, and I will show you what a basic setup is to get the temperature using our temperature sensor. Okay, so you don't have to replicate this exact setup, but according to the schematic that we've shown on the screen, you can see how we created a basic circuit here. So what we have is the yellow cable going from 5 volts all the way to the positive row here, and then from that we get power and pass it through the exact same column that the power connector of our temperature sensor is plugged into. Then we need some sort of resistance, and the resistance for this specific component, it connects to the output. So for that, we just connect the resistance to that, and then the other way leads to our power. Okay, so and the output, we just connect it up all the way to a digital pin here, so that I connected it to pin 2 in this case. And then just what's left is the easiest part, which is ground. So the leftmost is ground. We connect the same column to the ground that's coming from our Arduino. So we have successfully connected a circuit to this thing. How will we use it to get data? That all comes down to code. Okay, so for this next part, we will need a computer and a USB cable to connect the board to our laptop. So all we need to do to start coding for this, we can just search for Arduino IDE, and we can just go on this first link, accept the cookies, and I will just get the macOS part. I will just download, and I'm just gonna save it to my downloads folder. Okay, and once it finishes, we can just open the file. I'm on Mac, so I have to just drag it on my application, and that's it. Now we can delete the file that we just downloaded after ejecting it, and we can open the application. Trust it. Allow access to my documents folder, and this is what you will be greeted with as soon as the IDE opens. It's a blank code project. How code works for Arduino is two basic parts. We have a setup part that just takes everything that we need to set up, all the code that we only need to run once at the start of our application, and it will run that. And once that's done, it will go into the loop, and it will just go through the loop indefinitely. It will never stop. It will keep going like an infinite loop. So this is what will happen once. This is what will just keep happening at every step of the however much we have the board operating. Okay, so you don't need to know a lot about code, but you need just a bit of coding experience, because this language is very, very easy. It's similar to C. It's also got some Python components baked into it though, and you will see why in a bit. So I will replace this code with the code that we need to run our project here to just get the temperature from our sensor, and I will see you back when that's replaced. Okay, so I've connected the board through a USB-C cable to my laptop here, and we have the option to connect to it from this list. So that's how you can see that it works. If it doesn't work, try another cable, try another port on your computer, and it should show up, and you should be able to start using it, no problem. So this code, let's just go through it step by step, see what it does. We have two libraries that we need for these for this component, the digital temperature sensor, and you see that it's giving me an error down here because I don't have these two libraries installed yet. We'll fix that just now. And then we just need to define the digital pin that we connected our output to, and in my case, remember that's pin 2, so I'm just going to change that to the code. And this is just some initialization to, we don't need to exactly know what this does, but we just need it to initialize the bus. What the bus is it will take lots of inputs from lots of different components that we have connected digitally. We only have one, so we're not going to get into too much detail about that. And then we have our setup. So we initialize our serial input. What that means is like it's digital input. Again, no need to worry about this. And also we start our sensors up on this line. Then in the void, we just request the temperature from our sensors, which we defined before, and we just print the temperature. But how we print it is we do serial.print. Serial is just, again, it's an output that we will be able to monitor here on from the computer. You can also connect at the future stage a whole LCD screen onto this board here, and there's no need to have it connected to a computer at all. You can just have the temperatures display on the screen. Okay, and then we just get both we print the temp in Celsius. Here's the C part, and then also in Fahrenheit. And then we just stop for a bit, for 1 second. And then we repeat this whole thing again and again. So we just request the temperature and print it out through this line here and through this line here. So now we need to fix these two libraries that it can't find because they don't come bundled with. So what you can do is go to the toolbar and go to Tools, Manage Libraries. And then there's two libraries that we need. One of them is OneWire. So you can just type it here, search it. And it's this one here. So I'm just going to install that. And then the other one is Dallas Temperature, because that's the name of the company that does these sensors, like the one that we have here. Let's install this. This is the right one. We don't really need the dependencies because we just installed OneWire. It was a dependency. So we can just ignore all the others that we have here, and we can verify the sketch first. The sketch is our code that we've written. Always verify before you upload to your board, just in case something goes wrong. So I'm just going to click on verify here, and it's going to compile. It should compile with no errors. Wait for that to finish. And this message that we get down here is good. We want this. And then we can just upload to the board. Here we see the progress of it down here. And it will automatically restart the board. Okay. So now how do we test that it's working, right? We need to see this serial thing that I've been talking about before. It's just an output through USB. Think of it that way. So we'll just find the, I think it's in Tools. Yeah, it's in the Tools. It's in the serial monitor option here. And here we go. So we see that our board with this circuit that we just implemented, it outputs the temperature right now, both in Celsius and in Fahrenheit. It will keep doing that every 1 second, approximately. Okay, I know that can be a lot to take in, and we skimmed through very, very important concepts very quickly, but the point was to just make you feel a bit more relaxed with the topic. If you have that very, very basic electricity knowledge, you know how to make a circuit, you will love breadboards. It's a thing that just lets you make circuits very easily. And if you have that bit of curiosity about coding, this is the perfect kind of project for you to get started with. It's very cheap. You can get all of these components. We'll have them listed in the information section of this workshop, and you can get everything that's needed here to replicate our project. We've used a temperature sensor because it's a very relevant sensor to use, especially when thinking microgreens. And this is how we can get a very basic temperature reading to our console. Again, don't be afraid to experiment. Try purchasing all sorts of components and try adding your own spin on this project. Let's say you can have 3 LEDs that can be, the red one maybe will turn on if the temperature is over 30 degrees Celsius, or the green one will turn on if it's below that. It's just an idea, but you can really connect anything you want to this thing and you can mess around with it. There's all sorts of kinds of boards. It's not just the Arduino Uno, and it just takes a bit of curiosity, I think, to get started. Once you go into each of these topics, a bit of electricity, a bit of coding, and a bit of an idea what to do with this stuff, because I think the main difficulty for people is finding a project to work on. For us, that's microgreens. So we can hook this up with another humidity sensor to our microgreen, and it will just sit there and work. We don't even need to connect it up to the laptop anymore. We can just remove it because the program is now built onto it. So we can just add this 5-volt DC that we've shown before, power to it, and it will just work. This also has Wi-Fi, so it can send off this data to whatever thing we needed to send it to. Thank you very much for joining, and please see the attached schematic if you want to replicate this setup at all, and please try to mess around with it yourself, because it's one thing to watch something and another thing to do it yourself. You will learn just so much by doing it, maybe popping a couple light bulbs on the way, but it will for sure be an interesting project no matter what you do.